All right, Yishay Carmiel, AI leader at Avaya, and one of my go-to people to talk to when it comes to speech technologies. Welcome to the Data Exchange podcast.
Thank you, Ben. Thank you very much for inviting me.
So I actually had Yishai on my old podcast, The Data Show, and there we kind of talked about the basics of building a speech application. So this is more of a follow-up and more of an update on what's happened in the field since then. So first of all, Yishai, I actually coincidentally, as we're recording this, I just invited Bo Lee from Google to give a talk at the NLP Summit, a conference I chaired. Um, and he talked about end-to-end speech systems. And in
Right.
our previous conversation, actually, you did a great job explaining to people why speech is challenging because there's so many different components, right? So to building a speech application. So what is this end-to-end, uh, this trend towards end-to-end? First of all, so two questions right off the bat. What is it? And two, what is the state of it?
Okay. So that's a great question. So long story short, speech is very hard, especially speech recognition. And the key thing is that if you're thinking about it, let's go back to speech 101 just to understand how speech recognition system works. So basically, we can say that every speech recognition system is divided into three types of models. So the first model is what we call the signal processing model or the feature extraction model, when you have some kind of a waveform and you are trying to extract, you are trying to enhance it in some extent, and you are trying to extract features, which basically it's like every process in a machine learning process. We're trying to find some patterns. The key thing that that usually these are non-trivial processes. So there is some work and there are some specific type of models and code bases that are aimed for that. The second type of model is what we call the acoustic level, which we are trying to classify these different type of features into different type of sounds. And then we have the last part, which is called the language level, which we are trying to combine because we assume that these sounds were produced by a human being and they have some meaning. So we're trying to combine these sounds into words and into languages. And the key thing is that the development of a speech recognition system, because if you're thinking about it, speech recognition as research has been around for the past 50 years. So it's a very evolved field, and it's also a very, very complicated field. So one of the things that is happening today or happening until a year or 2 years ago is that in order to produce something valuable in the terms of speech recognition, there have been a big learning curve. And the open source tools were quite complicated. And, and that in the past few years has been changed because what we call end-to-end systems are trying to reverse the map and create some kind of a single neural network that takes the waveform or some kind of extension of the waveform like feature extraction and produce some outputs. And the interesting thing about it is that if like a
So
few years ago,
in essence, you still keep the model for extracting the features, the signal processing, but then you only have one model to do the rest. Is that right?
to some extent, sometimes there are some works that they are working directly on the waveform. Because if you're thinking about it, you can take some kind of, there are some works that instead of the classical signal processing algorithms, they are putting some kind of a convolutional neural network. So if you're thinking about it, we can take a convolutional neural network past this end-to-end system, so it can be a single neural network. But basically, most of the works are working on the things that we are calling log filter banks, which some kind of a version of the signal processing. And up until a year ago, it was nice. Everybody got excited, especially like the non-speech guys, the non-classical speech guys were excited about it because people were able to create some interesting speech-based speech recognition applications on top of that. But right now it's getting a lot of attention because the quality is better. The quality is better than the classical speech systems, which
So
is
by the
becoming very
way,
interesting.
Yishai, for those of us who are not in speech, so I'm assuming in speech there's uh, well accepted benchmarks that people use. So when you say someone
Yeah.
gets excited about something, it's because this end-to-end model is doing well in these benchmarks.
Yes, yes. So again, when you are so the interesting thing about speech is that you have multiple benchmarks, because you have the classical benchmarks, what we say that it's some kind of closed talk microphone, very without any noises, and then you have the very challenging benchmarks when, like for example, challenges that we're using in Alexa and Siri, which is far field speech recognition with a lot of noises. So in the classical benchmarks, end-to-end systems seems to be on par or even slightly better than what we call the hybrid systems. And just one thing that is important to say, when I'm saying the so-called classical systems, these are very, very advanced deep learning systems. It's not, no, they incorporate a lot of, cutting edge deep learning systems, but they are still include some of the classical aspects of what we call HMM, hidden Markov models on top of that.
I see. So then these end-to-end systems, you said you were alluding to people got excited, but then you said you used but. So there was a but there.
Yes. So the key thing is that if you're thinking about what is needed to be done in order for an end-to-end system to be adopted, is what we call streaming end-to-end systems. Usually, when I'm thinking about the cutting-edge speech recognition system, it's what we call a real-time speech recognition. That 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 while I'm talking, the system already recognizes me, already does some recognition. In the end-to-end systems, there isn't some kind of an open source, or there isn't some kind of open architecture that you can use in order to create some kind of a real-time speech recognition. So it's what we call semi-offline. You are uploading some kind of a wave, it does its magic, and then you're getting the recording. But if you really want to do something valuable in terms of speech recognition, real-time speech recognition end-to-end systems, represent the future.
But you said so you used the phrase open source. But set aside open source. Are there commercial systems that can do this in real time, end to end?
Yeah. So, for example, Google released their offline speech recognition that you can do on the Android. This is based on an end-to-end
Yeah,
system. It's called RNNT.
on the Pixel phone, right?
Exactly.
That system is insane. I mean,
Yeah.
I got a demo in a loud coffee shop. My friend put it on airplane mode, so no connection. I mean, so we started talking. It just was transcribing accurately in real time.
Yeah. It works amazingly well.
Yeah.
But the key thing is that if I want to implement RNNT, there isn't some kind of an open source or some kind of a code that I can do that out of the box and implement that.
But
And
generally, speech is complex enough and also important enough. I mean, are most models really open source in speech?
so to some extent, there are some models. Again, so it's a challenging question. It's not that we have the development in speech is like an ImageNet or in MLP that they already had what we call their deep learning revolution. So speech already had the deep learning revolution, but the development is challenging. I think that right now, one of the things that people are thinking is to take the same thing and to convert it into speech, that there will be a lot of open source models, easier tools to collect data and to augment data in a much more suitable way, and that it wouldn't be some kind of so-called closed ecosystem that not a lot of people can do development, but rather that to open the ecosystem to much broader developers. And I think
But
then
but if you look at
it'll
the
be much
history
interesting.
of the speech industry, I've never gotten the impression it was open. Like you had new ones, IBM, Microsoft, Google. Google is in the cloud. So are these models really? Has there been a tradition really of openness?
Yeah, so back in 29, 2011, don't catch me on the date. So there was an initiative by John Hopkins and a few other universities to create an open source, because they said exactly what you're saying, is that it's some kind of a closed ecosystem that if some kind of a developer, some kind of a startup wants to develop their next revolution of speech recognition, there isn't an open source or there isn't a framework, a good framework to do that. So they created an open source which is called Caldi. And Caldi is literally the open source for speech recognition. Every company that respects itself,
So
that is
now,
doing,
so before you describe Caldi, let's put Caldi in the context of what we were discussing earlier, which is speech can either be end to end or has modules. So where does
yes.
Caldi? What is Caldi?
So Caldi is, is the full package of all these models. But it's most of the development in Caldi is what we call the classical system, like what we call the hybrid system, the HMM with the deep learning model. So it has a feature extraction model, it has a language model package, it has all the acoustical, it has all the training, it's all the models. The key thing with Caldi is that it's a non-trivial package. It's really non-trivial package. I've been working a lot of Caldi. I think that it's amazing. The key thing is that it's C++ code plus a lot of shell scripts and Perl scripts, and the configuration is not trivial. So it's not like we have the development like PyTorch and TensorFlow,
Right.
which every kind of developer can get into that. It's in Caldi is much more challenging, and that is why people, the developer of Caldi, are thinking about the next generation of this framework and to integrate that with one of the interesting frameworks like TensorFlow or PyTorch.
So does Caldi have an end-to-end component?
Not that is mainstream. Caldi doesn't have an end-to-end component, and there is a new framework which is under development right now, which is being developed, which will have an end-to-end component, which is like the new version of this stuff.
So for those of us who are not in speech, so is Caldi kind of like the TensorFlow or TensorFlow and PyTorch combined in speech? It's like the the library that most people in speech are using.
Yes. Today, without a doubt, in the future, there's going to be a new version, which is like what we call the new version of Caldi, which is called K2, and which will today, if you want to do in 2020, end of 2020, you want to do development, Caldi is details to do that.
So if I if
If you
I
want to do leading edge.
so if I go to archive and read one of these leading speech papers, and I follow their code to GitHub, so Caldi is going to be involved in most likely. Is that right?
If it's not end to end, yes, to some extent. So again, one of the things that a lot of times, people, I'm not sure that they are publishing their code into GitHub, but they're saying, okay, we compared it into Caldi, we use this and this type of script and into Caldi. The key thing is that it's quite challenging to reproduce some of the works in speech because of the complexity of the system. And the speech guys understand that we're trying to make it much easier to develop
So
in the future.
what's your sense of end to end in 2 to 3 years? Is end to end going to be the de facto?
I think so. It seems like that. It seems that that until a year ago, some people were skeptic about it. I think that right now, it seems that it's much more matured, and it represents the future of speech recognition, and also it also represents the new type of architectures and an easier development schemas that are going to happen in the speech recognition field. So when you're thinking about when you're thinking about development, or you don't think about just accuracy. Think about the simplicity to create new type of neural network architectures, new type of applications. So end-to-end representing the new type of schema, it will be easier to do that.
So let's take that example that I described earlier, which is that awesome ASR system on the Pixel phone. So I'm assuming that was Google trained a gigantic model, distilled it, put it on the phone, right? So then is that small model in the phone, how would you describe that? Is that an end-to-end system?
Yeah, it's an end-to-end system. It's an end-to-end system. So think about it, how complex this model is in development. So you need to, to train a model. You need to collect a lot of data. You need to train the data, and you also need to distill the model and to make sure that it's working and it's gathering, all the information, it's outputting all the right stuff. So one of the things that people are thinking is how to make Slack, to the average developer who doesn't have millions and millions of dollars of budget, how to do his or her life easier by creating better development tools.
So, Yishai, that example again of the Pixel phone that I cited earlier, where my friend and I were talking in a loud coffee shop in San Francisco. So, obviously, the first step there is that feature extraction. What you called in the old days, they would be using signal processing. So, is that still what they're doing, you think?
Well, yeah, no. Um, if you're thinking about what is happening in these, cutting edge, systems, there are also a lot of, signal deep learning and machine learning based signal processing algorithms that are trying to get much, better clean data. So one example is what we call voice activity detector. Voice activity detector is that I'm just, if you have some kind of a signal and you have noises, so I want to extract just the speech parts and to remove all the other parts. And in the back old days, it was, we use some very, sophisticated signal processing algorithms. Now, these algorithms are based on some neural-based models. So even if you are thinking about, these simple algorithms like, speech extraction or voice activity detectors, they are based on very, very, non-trivial, neural networks architectures.
So we just went through and got an update from you on speech to text. So this is speech recognition. Now let's briefly get an update on text to speech, which, by the way, I have a pet peeve. I sometimes want to have a newspaper article read to me while I'm doing something else, putzing around the house. When I go to one of these websites, I put in the URL, the system starts reading the article to me. Oh my God, it's so boring and dry and expressionless. So where are we, Yishai, in terms of the best models for text to speech?
Okay, so text to speech is another type of revolution. So let me just
Okay.
give some kind of a brief history, and I'll tell you why I'm saying a brief history, because our last podcast was in June 2016, and the first revolution happened in September 2016. So I didn't have a chance to talk about it. So, so text to speech basically before what we call the pre-WaveNet era, it was a very, very complicated, task, because you needed to collect a lot of data. You applied, some very, very non-trivial machine learning algorithms, how to concatenate the data, how to apply what we call prosody, which prosody is what you're saying that, the system is, has some kind of emotion or some kind of, they're reading the in much more natural way. And what we have is that usually we have a metric that is called mean opinion square. Mean opinion square is, you're just, playing the system to multiple people, and you're asking them to grade, the system from 1 to 5, and then you have some kind of an average, some kind of a crowdsourcing average of what's going on. And in September 2016, researchers from DeepMind created a neural network which is called WaveNet, which sounded amazingly well. And in addition that it sounded amazingly well, one of the things that it was doing was some kind of a neural network. And it opened the door to a lot of people who didn't really understand about text to speech and all the complicated systems to do that. The one hurdle, the small one hurdle, if I remember correctly, that it took 90 minutes or back then to synthesize one speech. It was super complicated and super CPU
So
consuming, to
you
do that.
said
And then there were
so wait, so you said 90 minutes to do what?
generate 1 second of speech back in September 2016.
Wow.
Okay, so basically, people didn't think about real time. And then researchers from Google created some kind of, an amazing system which is called Tacotron. And just one anecdote: the reason that it's called Tacotron is because the authors really like tacos, so they call it Tacotron. this is appears in the paper, and and it sounds as really it sounded it incorporated more. I wouldn't get into technical details, but it incorporated more modules that were able to create some kind of what we call the end-to-end text-to-speech system, basically from text to the synthesized speech. WaveNet was just one part of the equation. And then they created another version, which is called Tacotron 2. And right now, the systems, if you go into these type of architectures, the systems worked amazingly well. They sounded really like a human being. As an example, if you remember, or if your audience remember the demonstration that Google has done in 2018, the Google Duplex, it really sounded like a human being. So these are the qualities that we're talking about. So that was 2017, 2018. And then it opened the door to a variety of applications. So
stop there. So 27, 2018, lots of interesting happenings, but it seems confined to Google and DeepMind. So what about systems outside of those companies?
So NVIDIA and other companies have open sourced these implementations in something like 2019, 2018, something like that. And then you can, if you want to use some kind of, cutting edge Tacotron 2, you can find it online and you have some kind of implementation even with pre-trained models. And the interesting thing about it is that the development is pretty easy because it's some kind of neural network architecture. It's pretty straightforward how to train this system, or to some extent pretty straightforward. So people can do very, very interesting applications on top of that. And then the development is split into two interesting things. One of them is an interesting problem in text-to-speech, which let's assume that I created the text-to-speech based on your voice again. Okay, so I recorded your voice like a few tens of hours. Okay, but right now I want to create a text-to-speech based on my voice. Okay, so the question is that based on a few samples or a few seconds or a few minutes of my voice, can I create a system or do some kind of a transfer learning that the system will speak in my voice? So the answer is yes. So Baidu started to do that. So this is called the multi-speaker TTS systems. And it opens the door to a variety of applications. So
where are we for text-to-speech as far as if I'm a developer now and I want to use a text-to-speech system, say in the cloud, how good are the systems that a non-expert has access to?
They are really good. They're really good. And I think that Google Cloud open source the WaveNet, and Amazon AWS they have Amazon Poly, and the qualities are amazing, and they're really good. But they know. But one of the things that is challenging is that there are still offline systems. So even though that it takes much faster than these WaveNets times 90 minutes per 1 second, it's much faster. These systems are still what we call offline systems. Okay, in the past 6 months, both or 9 months, Microsoft and Facebook and Tencent and a few other companies created what we call real-time text-to-speech systems. So they took the classical what we call Tacotron systems and more advanced systems, and they really accelerated them by 2 orders of magnitude.
But that's still slow.
No, actually, that's faster than real time.
Okay.
So when I'm saying that the Tacotron or these systems, it took a few seconds or a few minutes to generate a few seconds of voice. Right now, based on the recent papers, I can generate 1 second of voice in less than 200 milliseconds. So basically, I have some.
So the systems that you're just now describing, are they out there or are they research?
So that's an interesting question. So they are research, they've published papers, and we are seeing the first sprouts of these implementations in GitHub. So if you're looking carefully and you know where to find and to trust the code, so you're seeing the first implementations of GitHub, which is starting to be very interesting. The key thing, and this is something that I should mention, is that the development of these text-to-speech systems opened the door to do some um, deep fakes and audio fakes, which is why we need to be very careful about this stuff.
So um, we talked about, so the two main parts of speech technologies is speech to text and text to speech. And I think conversational assistants, that's a ways off, just because based on what I know about chatbots, obviously speech assistants are even harder, and that's just
Yeah.
plain text, right? So let's go and talk about since speech technologies really involves machine learning, so in both the speech to text and text to speech. So I'm assuming speech itself also has similar challenges as other forms of machine learning. So, for example, in machine learning now, people, Yishai, are talking about responsible AI, right? So speech also must have challenges around fairness and bias, right? So, what, like I know that some speech systems, maybe I think Alexa was found to be very poor performance when it comes to people with accents, or weren't speaking with perfect American English. So what is the state of this type of discussion inside the speech community? Is this something that people are talking about as well?
Oh, without a doubt. So I think that one of the biggest problems with speech is that if you're thinking about it, go to Google. So Google, the offering that Google has. So they have around the best offering. They have around 120 languages, and I think there's they open in the Google Cloud. The key thing is that you have 7,000 spoken languages in the world. So one of the biggest challenges, in creating what we call generally in creating human language understanding applications, is that the support or the quality of the quality of speech recognition systems today is that they only support around 1 or 2% of the spoken languages, and there are a lot of languages, although some of them are not common, that are not being supported.
And by the way, when unlike when people write, where they might write even more carefully, when people talk, they may even go back and forth between languages, right?
Yeah.
Like
So
they
so
might pepper their conversation with a little bit of Spanish, or if it's a Chinese speaker, a little bit of Mandarin, right?
so the key thing is that when you are trying to analyze conversations, it's much harder than analyzing text. So basically, there are two things. If you're thinking about even on our conversations, people talk very differently than they write stuff. So it's called, it's a known phenomenon in what we call conversational AI, which is called spontaneous speech. Okay. So what we have, grammatical errors. We have what we call repetitions. A lot of people are saying and and all, and different sounds. And when you're writing some kind of a text to someone, you're not writing all of this stuff. The second thing is that speech recognition system. Let's put aside the ideal environments that it's a very close microphone, it's a very clean environment without any noises. Usually, what we call the word error rate, which is the classical metric to evaluate speech recognition systems, can be between 15 to 40% errors. So think about that. That when I'm getting the output text, just the output text from the speech recognition system, 15% to 40% of the text is not right. So then I need to apply my NLP magic on top of text that is very, very noisy. And also take into consideration is what we call, what we call the raw text. It's not punctuated. It's not capitalized. It's not, even when I'm saying some kind of a number, I don't see the numbers. I see just plain text. So there is a lot of machine learning work just to convert, these transcriptions into some kind of a plain text or some kind of a text that we can just apply some NLP magic on top of that.
What about Yishai, the data sets that people train on? So I think, for example, in computer vision, there have been cases where it surfaced that the training data was not particularly representative of the general population. So is the speech community looking into the data sets and benchmarks that they're using for benchmarks?
Yep. Yep. So the key thing with data sets is that we have multiple data sets. Not a lot of them are open source, and one of the things that some some there are some open source initiatives to do that, like Mozilla Common Voice, which are trying to create some kind of unified platform to collect speech data. This is one aspect of that. The key thing is that also data annotation is pretty hard in the speech, because for every type of audio recording, you need to provide the transcriptions. So it's a very, it's a very tedious and manual process to do that. So, in opposed to images, when you just can type or just segment, the annotation, the data annotation is much easier. In speech, it's much more tedious and much more time consuming. So the data collection is much more challenging. That is why you don't have a lot of open source data sets.
So so the people who build speech systems, Yishai, did they talk about did they assume that their system is always going to be used by friendly users, or did they make the assumption that, hey, some of our systems can be attacked as well? Because wasn't there a funny example of South Park trolling Alexa in one of the
Right.
episodes of South Park? So, but that was just a funny example. But but generally, that kind of showed that all the all these systems based on machine learning are also subject to attacks, right? So
Right. So are you referring to what we call adversarial attacks, or just just the quality of the systems? There are two aspects of that which people are researching.
I think adversarial attacks, is that something that the speech community thinks about?
Yeah. So of course, the speech community is thinking about the adversarial attacks, and there's been a few papers about how we can manipulate
Yeah, because
even personal
you
systems.
can imagine a system in a more mission critical situation, right?
Right. So there's been some very interesting research about that. There's been even some kind of research recently that we're able to show that I can definitely attack you know personal assistants like Alexa and Siri. Like so some researchers bought some kind of smart speaker, and they're able to show that with some sophistication they're able to manipulate what the system will recognize, although the recording sounds to a human being that that it's totally different. So basically, I'm saying one thing and the system recognizes another thing. So yeah, of course, there are multiple aspects of that, and also there are the classical aspects that people are super smart, and sometimes we don't know what to expect of the people to say, and we need to make sure that the
But
system
and
understands.
also the other thing is that we're really in the early phases of deployment of many of these systems. So you can imagine if these systems are more widely deployed, who knows what the black hats would do with them, right?
Yeah. So right now, I think that these are like we're just starting to see these things, okay? And again, we don't know. It's not really common. And more one of the things that people are starting to see is the usage of audio fakes and some manipulations over there, which is much easier to do. And that's people are starting to get attention to that, how to prevent or how to identify audio fakes.
It seems to me that speech technologies, people accept that it's a black box. Maybe I'm
Oh,
wrong. Maybe you know better. You're closer to this than I am. Whereas in other areas, Yishai, people are wanting more transparency and explainability. But speech, it's too complex. I just accept that it's a black box. Is that a fair assessment, or are there situations where people want more transparency?
well, I think that right now I think that speech basically it's just one part of the equation. People, if you're thinking about it, people or customers don't really care about what we call speech recognition. Sometimes they even consider speech recognition as a commodity,
Yeah.
even though the systems are super complicated, like bleeding edge of deep learning. They're saying, okay, we have offerings by AWS or by Google Cloud, so they are considered as a commodity. The key thing that people consider is what we call downstream tasks. Think about that when I'm saying to Alexa, play me Lucy in the Sky with Diamonds. We don't really care if Alexa recognize the words. We just care if he played the song or didn't play the song. So
Or
people are
yeah,
just
yeah, we don't care about the details of how it did it, But maybe the one thing we care is what is Alexa going to use with all this information that I'm telling her, or right?
Yeah, yeah, okay.
So I think that's still something that people care about, right? Even with a
I think
black
that
box system.
people, yeah, I think that people really care about privacy, and we're starting to see that even um, how to use privacy and machine learning. And I think that definitely we are going to see some interesting applications of privacy preserved machine learning being done on speech, especially in what we call multi-party computation and federated learning. I think that we are still it's still early.
I'm glad you didn't say homomorphic encryption because that's another slow system.
Yeah, yeah,
um, yeah, it's interesting that people. I guess it makes sense that people are more accepting that it's a black box. By the way, Yishai, in the chatbot world, a couple of things that I want to ask if it maps over to the speech world. The first is in the chatbot world, it seems like people have acknowledged that look, we actually need people with different backgrounds. To work on these systems. One, just so that to make sure this system is inclusive and fair, but also because we actually need many different skill sets. Like for example, in chatbots, they may want people who are actual writers to write out some of the dialogues, right? So to make it more engaging or or more realistic. So this notion that when you build a system that's going to represent your company, you want to make sure you bring in basically the equivalent of the new UX designer, which might be the writer, right?
right.
Um, and then secondly, the second trend in chatbots is the community has acknowledged that they were hurt by the initial hype. So now they've tried to come up with levels, 5 levels of autonomy, similar to the 5 levels of self-driving cars. And then they're saying, okay, so we're only actually our technology is only at this level right now. So let's not get ahead of ourselves. So so then two questions for you on speech.
Exactly.
One is are when building speech applications, are people drawing people from other disciplines, humanity, social science? Secondly, how does the speech technology manage expectations on the part of the public in terms of the sophistication of the system?
Okay, so the second question is a very challenging because one of the things is that um, you always need to make sure that you connect the science and the business. So pre 2014 or pre 2015, people were saying, "Oh, speech is not it's not applicable. It doesn't recognize me, so it's not working." But right now, because we have tens of millions or hundreds of millions of people talking to Google Assistants, to voice search, to Amazon Alexa, and to Apple Siri, so we are flipping the side of the equation. People think that everything is possible, and we are just around the corner. We're just around the corner that we are going to have some kind of a general AI that's going to have a conversation with us, and all of these problems are very challenging in what we call human language understanding. So chatbot represents one side of the equation when someone is just texting, just using
Right.
some text as an input. With speech-based application, we also consider that because again, as I said, we care about the downstream task. We don't care about the raw information that is being fed into the system. We care about what we call human language understanding system and trying to find what are the applications. So I think that right now we're in stage one because the quality of the system is not good enough. Just understanding or really understanding what's going on over there, it's it's not possible. And we see that also in text. We know it's we still have a lot of problems. So add to that another layer of complexity with how people are speaking and noisy systems and complicated systems. So we are really so we have a lot of we have a lot of work to do in order to make these things happen and realistic.
But realistically, most developers, as you point out, speech is hard. So most developers will either just use a cloud service or use some kind of either proprietary or open source library, right? It's too complicated. I mean, in many ways, they do that too for NLP, but even in NLP, developers can go in there and do some of the things themselves, do some of the tuning. And by the way, Yishai, so in NLP, one of the things that is interesting in NLP is now you have these big language models, but people have learned that uh, I mean, language is very domain specific. So even different disciplines within healthcare have very different vocabulary and lingo and jargon. So then people have come to appreciate that. Okay, so I have this a great general purpose language model, but I need to do some tuning and some sort of transfer learning to tune it. So I imagine in speech you have to do that too, right? So then
So
now, if I'm a developer and I use one of your systems, which is great, but then I just need to tune it a little bit for my area of finance or whatever. How hard is that to do?
so today, so that's a great question. So of course, in speech we're using language models, and we're using like the bleeding edge of language models, and sometimes. So of course, what you're presenting is what we call the long tail problem of human language understanding. That for every domain specific, I need to collect new data or new type of words, and even just new and so it's always today with the current systems, it's not trivial. Think about some simple words. Think about that. That I'll give you an example. Okay, so think about that the speech recognition in September 2019, it wasn't supposed to understand the word COVID. Okay, COVID-19.
Right,
Nobody knows. So it
right.
wasn't some kind of word that speech recognition was supposed to understand. Now it's a very very common word. So the systems needs to understand that. So I always need to update that. The second thing is that just updating the language models today, it's in the speech recognition system, it's a non-trivial process. Again, I'm not saying that it's not doable, but it's
Not
a
not not
non-trivial process.
necessarily not necessarily updating, but just tuning.
Yeah, so even tuning. So basically training a language model and from a classical natural language processing task, it's doable. It's not something that I'm saying that I can do that in 2 lines of code, but I need to collect the data. The key thing
Correct.
is how you connect the new language model or the new adapted language model with the speech recognition system.
Correct.
So that's something that is less trivial, and
I see.
also from a development perspective, it sometimes it creates a lot of challenges.
So again, going back, so I'm a developer. I need to use a speech technology in my application. I'm probably going to use some API or some third party library. Um, how easy is that
Or you
now?
can use NVIDIA, for example.
Or
So
NVIDIA.
NVIDIA, for example, like recently, NVIDIA recently released some, pre-trained models of speech recognitions, which seems to be
But
really
then
interesting.
all the inference has to happen on a GPU.
I assume. I don't know. I didn't check that. I
Yeah.
assume, but
Yeah.
it's still it's good. It's good because again, you have pre-trained models and you can use them, and they're saving you a lot of time and a lot of hurdles just to do that.
But do
So
these but do
sometimes,
the,
sometimes it makes sense if it's very fast on GPU. Why not?
but do these models learn over time? Though? So, for example, uh, so here's a UX problem in speech, right? So I ask Siri to do something, Siri gets confused, and then Siri actually might ask me, "So did you mean this?" So I say, "Yes," or "No, I meant this." Now I'm okay doing that maybe once, maybe twice, but if you ask me every time I want to turn the light, if you ask me a question, I will start getting annoyed, right? So how quickly can these systems get updated or learn?
Okay, so it opens the door. So now it opens the door to a variety of questions from a development perspective. Okay,
Right.
when I update the model, because do I have let's think about Siri. And again, I don't know what's going on under the hood, but let's
Right.
assume that we don't have a dedicated model just for Ben.
Right.
Okay. So, the question is that do I update the model every time that any user says something to the model, or do I update the model every once in a while just to make sure that I'm collecting the data?
Now
Uh,
for Siri, maybe there's some kind of local model, right?
So there are some, so there are some local models and there are some adaptations how to do that, how to create some kind of, a combination of, user specific, problems, with general purpose models. So, and again, these things are from a human language understanding perspective. When you are thinking about that, there are a lot of challenges. Putting aside the technology, putting aside the accuracy, putting aside, let's assume that we can do all of that stuff from a technology perspective, from a development perspective or production grade perspective of these systems, there are a lot of very, very challenging problems. Because the question is that let's assume that I need, this some kind of a real-time, what we call human language understanding system. So, and I have 500, different domains that I collected the data, that I know how to train the data, that I know how to adapt the data. Do I need, right now, to support 500 different models running in real time? And how to allocate them properly? So these are problems that people are facing, and sometimes people are saying, okay, can we use a single model and just adapt the model, or some kind of a big model, and just go to the right stuff when we need some domain specific applications. So these are both algorithmic and research problems, but also production, problems that are coming from production.
So with that, so Yishai, if someone wants to get like a high level understanding of speech technologies, are there any specific books or articles you recommend? Not too technical, but just kind of a survey of state of the art.
Hmm. So
If you can't think
I
of
think,
it now, just send it to me and then I'll add it to the notes to the episode.
yeah, I try to find something that is not too technical.
Yeah,
Okay.
yeah. Good, thank you, man. This was great. Actually, we went through a lot, and it's a really great update of this very important uh, set of technologies that people just take for granted. There's a community around it, and then we just kind of assume that you folks will take care of all our needs.
Yeah, we try our best.
Yeah. Thank you.
Excellent.